Question number 1. We have to show that the function 3x plus 17 is strictly increasing on real numbers. To check whether it is increasing, strictly increasing or strictly decreasing, we need to find the derivative, first derivative of the given function. When we differentiate this 3x plus 17 with respect to x, we get 3 into 1 plus 0, that is 3. Whatever the x value, we get the derivative as a positive number, it is a non-zero number. So f dash of x, if there is no possibility of getting 0 in the derivative by substituting the x value, we write it as greater than 0. By substituting the x values, if you are getting 0 in the first derivative, then we'll write greater than or equal to 0. That alone you remember. If you are getting 0 as an answer in the derivative, then it is increasing. If there is no chance of getting 0 in the first derivative, then we say it as strictly increasing. Here there is no chance of getting 0 in the first derivative, as the answer will be 3 irrespective of the x values. Therefore, the function is strictly increasing on whatever the x value substitute. It will not affect the derivative as it is a constant value. So that's why for x belongs to real number, this function 3x plus 17 is strictly increasing. Question number 2. Show that the function f of x equal to e power 2x is strictly increasing on real number. It is similar to the first question. So you'll find the derivative. It will be 2 e power 2x. Whatever the x value, this e power 2x remains positive. And 2 is also positive. Positive into positive will get positive value. There will be no chance of getting 0. Though you substitute x as 0, e power 0. Any term power 0, we get the value as 1. 1 into 2 will be 2. There is no chance of getting 0 in our first derivative. So therefore, f dash of x is greater than 0. The function is strictly increasing on real number. Whatever the x value substitute, this remains positive. Question number 3. F of x is equal to sin x. The derivative will be cos x. So first subdivision, they have given the interval as 0, 90. Before doing this question, as the derivative is cos x, we will draw the graph for cos x. So minus 1, 0, plus 1 in the y-axis, and 0, 90 degree, 180 degree, and 270 degree, 360 degree on the x-axis. We know cos 0 is 1. Sorry, this is plus 1, this is minus 1, extremely sorry. So cos 0 is 1 and 90 is 0, 180 is minus 1 and 270 again it is 0. For this alone we'll do. So 0, 1, 0, minus 1 and here it is 0. Again for 2 pi it is 1, it goes on. Okay. The given is 0, pi by 2. If the curve is above the x-axis, that means above the origin, the function is positive. We don't have any chance of getting 0 as it is an open interval. Therefore, the derivative will be greater than 0. The function is strictly increasing on the interval 0, pi by 2. Next subdivision, x belongs to the interval pi by 2, pi. Okay. So the derivative f dash of x, that is cos x, for 90 to 180, the curve is below the origin, that is negative. Therefore, it is less than 0. It is strictly decreasing. And the third subdivision, x belongs to the interval 0, pi. So for 0, pi, we can divide it as 0 to pi by 2 and pi by 2 to pi. If you check with 0 to pi by 2, it is increasing. Pi by 2 to pi, if you check, it is decreasing. So within this 0 to 180 degree, we have both increasing and decreasing. So therefore, we cannot conclude either it is increasing or decreasing. So f dash of x is neither increasing, strictly increasing, or neither strictly increasing or strictly decreasing, as both the possibilities are within this interval. Question number 4. Find the intervals in which the function is given by f of x is equal to 2x square minus 3x. The derivative as usual will do, it is 4x minus 3. To find the x value, we will equate the first derivative to 0. Okay, that is 4x minus 3 equal to 0, x is equal to 3 by 4. Draw the number line, plus infinity, minus infinity, and we have 3 by 4. So we have two intervals, minus infinity, 3 by 4 and 3 by 4, infinity. Okay, when x belongs to the interval minus infinity, 3 by 4, all the values are less than 3 by 4. But if you check with the signs, the numbers will be greater than 3 by 4. Greater number is minus, smaller number will be plus. Then we'll get as negative. If greater number is plus and smaller number is minus, then we'll get the answer as plus. Let us check. So f dash of x is 4x minus 3. That is 4 into negative number minus 3. So we'll get plus into minus minus. So negative minus negative number will get as negative. So this is less than 0. We don't have any possibility of getting 0 as these are open intervals. That is, these values are not included. So we'll get strictly decreasing on the interval minus infinity comma 3 by 4. When x belongs to the interval 3 by 4 comma plus infinity, we have f dash of x is 4x minus 3 and all the values are positive. So 4 into positive number minus 3, this will be positive. So greater number is positive, smaller number is negative. So we'll get as positive number. That is greater than 0. The function is strictly increasing on the interval 3 by 4 comma infinity. Okay. Question number 5. F of x is 2x cube minus 3x square minus 36x plus 7. We need to find in which intervals the function is strictly increasing and strictly decreasing. The derivative will be f dash of x is 6x square minus 6x minus 36. To find 0, we will equate the first derivative to 0. 6x square minus 6x minus 36 equal to 0. Taking 6 as common, we will get x square minus x minus 6 equal to 0. Factorizing this, we get x minus 3 into x plus 2 equal to 0. Okay? So we have the simplified form. And finding the values, x minus 3 equal to 0, x is equal to plus 3, x plus 2 equal to 0, we have x value as minus 2. On the number line, minus infinity comma infinity, we have minus 2 and 3. So we have the interval minus infinity comma minus 2, minus 2 comma 3, 3 comma infinity. We will discuss each interval one by one. When x belongs to the interval minus infinity comma minus 2, all the x values surely will be a negative value. And the simplified form of the first derivative is 6 into x minus 3 into x plus 2. Since all the x values are negative, negative minus a negative number will get a negative. Then negative plus 2. The numbers when you check it is greater than 2. Yeah. So it has a negative sign. So greater number negative, smaller number positive. We'll get a negative sign. Negative into negative positive, outside a positive number. So we get positive. F dash of x is greater than 0. Therefore the function is strictly increasing on the interval minus infinity comma minus 2. Then next interval, when x belongs to the interval minus 2 comma 3. That is, the x values are lesser than 3 but greater than minus 2. The derivative is 6 into x minus 3 into x plus 2. Here, if you check, the values are less than 3. That is, smaller number is positive and greater number is negative. So greater number negative, small number positive, when you subtract, it will be a negative number. And here it will be lesser than 2, so it will be a positive number. Negative into positive, negative, outside we have positive number, so negative into positive, negative. So f dash of x is less than 0, therefore the function is strictly decreasing on the interval minus 2 comma 3. When x belongs to the interval 3 comma infinity, if you check 3 comma infinity, all the x values will be positive, isn't it? And greater than 3. We have the derivative x minus 3 into x plus 2, outside plus x minus 3, all the values are positive and greater than 3. So greater number positive, smaller number negative, we'll have a positive number. And x plus 2, obviously, it will be a positive number as both are positive. Positive into positive, 6 is positive. So we get a positive number. That is, f dash of x is greater than 0. The function is strictly increasing on the interval 3 comma infinity. Question number 6. Find the intervals in which the following functions are increasing or decreasing. First subdivision, f of x is equal to x square plus 2x plus 5. Find the derivative. F dash of x will be 2x plus 2. We can take 2 as common, that is x plus 1. Equating f dash of x is equal to 0. We get 2x plus 1, 2 into x plus 1 equal to 0. Taking to the right side it will be 0. X plus 1 equal to 0, x is equal to minus 1. On the number line, minus infinity to infinity, we have minus 1. So the intervals will be minus infinity to minus 1 and minus 1 comma infinity. So when x belongs to the interval minus infinity comma minus 1, all the x values will be negative. So 2 into x plus 1 and it will be lesser than 1, isn't it? So Negative number will be the greater, 1 will be smaller. Obviously, we'll get negative number. So, negative into positive, it is negative. That is less than 0, strictly decreasing. When x belongs to the interval minus 1 comma infinity, all the numbers are greater than this minus 1. So, the derivative will be 2 into positive number will be greater, 1 will be smaller. Anyway, we'll get a positive number. So this is greater than 0. The function is strictly increasing on the interval minus 1 comma infinity. B subdivision, f of x is equal to 10x minus 6x minus 2x square. So when we find the derivative, it will be minus 6 minus 4x. When we equate to 0 to find the x value, we get minus 4x minus 6 equal to 0. We can take minus 2 as common, so it will be 2x plus 3 as minus into plus minus. And taking minus 2 to the right, it will be 0. 2x plus 3 equal to 0. X is equal to minus 3 by 2. Drawing the number line, it will be minus infinity, minus 3 by 2 and plus infinity. We have the interval minus infinity comma minus 3 by 2 and minus 3 by 2 comma infinity. So here all the values will be negative, and f dash of x simplified form is minus 2 into 2x plus 3. Outside we have negative number, and here since all the x values are negative, multiples of 2, again this will be a greater number, negative, smaller number, positive. So we'll get a negative. Negative into negative, positive. So we get greater than 0. The function is strictly increasing on the interval minus infinity comma minus 3 by 2. And when x belongs to the interval minus 3 by 2 comma plus infinity, the derivative is minus 2 into 2x plus 3. The values will be, and 2x plus 3 multiples of 2 positive number plus positive number will be positive. Negative into positive, negative. Since we get negative, it is less than 0. The function is strictly decreasing. C subdivision, f of x is minus 2x cube minus 9x square minus 12x plus 1. When we differentiate, we get minus 6x square minus 18x minus 12. To find the x value, we equate to 0. That is, I am taking minus 6 as common. So it will be x square plus 3x plus 2 equal to 0. Okay. So taking this minus 6 to right side, it will be 0. We get x square plus 3x plus 2. When we factorize, we get x plus 2 into x plus 1 into minus 6. To find the x value, we will take this minus 6 to the right side. So x plus 2 equal to 0, x is equal to minus 2, x plus 1 equal to 0, x is equal to minus 1. On the number line, minus infinity to infinity, minus 2 first, then minus 1. The intervals will be minus infinity to minus 2, minus 2 to minus 1, then minus 1 to infinity, plus infinity. When x belongs to the interval minus infinity comma minus 2, all the x values are negative. And the simplified form of the first derivative is minus 6 into x plus 2 into x plus 1. Okay. Since the negative numbers are greater, negative number, so greater number with negative sign, smaller number with positive, definitely we will get a negative value for these two. Okay. Outside we have negative. So negative into negative, positive into negative, we will get negative value. That is less than 0. The function is strictly decreasing when x belongs to the interval minus 2 comma minus 1. That is, the x values are greater than minus 2 but less than minus 1. The derivative is f dash of x equal to minus 6 into x plus 2 into x plus 1. If you see here, outside we have minus value. Since the greater number is 2, smaller number is negative, we will get a positive sign. And here if you see, we will get a negative sign as it is less than minus 1. Negative into negative, positive, positive into positive, we get positive. That is greater than 0. The function is strictly increasing on this interval minus 2 comma minus 1. When x belongs to the interval minus 1 comma infinity, the derivative is minus 6 into x plus 2 into x plus 1. All the x values are greater than 2 and 1. That is the positive numbers. Outside we have negative. Both are positive. Positive into positive, positive. Negative into positive, negative. This is less than 0. The function is strictly decreasing. Question number 6D. The function is given as 6 minus 9x minus x square. So we'll find the derivative. We get minus 9 minus 2x. We'll equate to 0 to find the x value. So we get minus 9 minus 2x is equal to 0. So minus 9 equal to 2x. and x is equal to minus 9 by 2. So we have the number line minus infinity to plus infinity and minus 9 by 2. We have the intervals minus infinity to minus 9 by 2 and 9 by 2 to plus infinity. Okay, so when x belongs to the interval minus infinity comma minus 9 by 2, the derivative simplified form is we can take negative sign out, so it is 2x plus 9. Okay, so we have the negative sign out, and for here all the x values are negative. As it is multiples of 2, it will be a negative. Now negative is greater number, 9 is smaller, it is plus, we will get a negative sign. So negative into negative positive, it is greater than 0, the function is strictly increasing. And when x belongs to the interval minus 9 by 2 to infinity, x values will be positive, and f dash of x is minus of 2x plus 9. That is outside we have negative sign, and here definitely it is addition and x values are positive, we'll have a positive sign, and minus into plus it is negative, that is less than 0. Therefore the function is strictly decreasing in this interval minus 9 by 2 comma infinity.